Okay, so let's look at the other one. Okay, so this is a scatter plot with a fitted regression line. Each dot represents one country. This is also in another plot from UNESCO report. And x-axis is the gender difference in self-efficacy. So we see the boys' self-efficacy index and the girls' self-efficacy index. And then the y-axis is the gender difference in science achievement. So boys' scores minus girls' scores. Okay. And the line is the trend line. It is an association, it's not a proof. Okay, this is just a trend line. So this chart is about association. It's not about group comparisons or trends over time because there's no time element. Okay, it's not a time series. What this chart tells us is that each point represents a country, showing how gender differences in self-efficacy relate to gender differences in what? In science achievement among top performing 15-year-olds. Very specific. Beyond that, we don't have evidence. So what we can safely say that there's a positive association. Countries where boys report higher self-efficacy than girls tend to also show higher male-female achievement gaps. Okay, that's one thing we can safely observe and say. The relationship is not perfect. There's a wide scatter, right? And what else? So this pattern appears across many countries, not just one or two, but we pretty much see in all the countries. So one careful takeaway is that gender differences in self-efficacy are related to gender differences in science achievement, right? Among top performing students, we don't know what happens to the lower performing students. This data is only showing us what's happening in the top performing students, 15-year-olds. Okay. Knowing these details is important because what this chart doesn't tell us is, this is where the critical thinking matters most, is that self-efficacy causes the achievement differences. We don't have that causal relationship. Whether higher self-efficacy leads to higher achievement or vice versa, we don't have that either. We don't have that support, we don't have that evidence. And whether both are driven by a third factor, like stereotypes, maybe school culture, the cultural narrative, we don't know, right? This doesn't tell us. And an individual level affects in which country, we don't know, right? What happens to the individual level? We have the aggregate. Another important thing that we should be observing and not overclaiming is that whether this relationship is actually statistically strong. We don't have any information just by looking at this chart. Maybe they put in the report. You can check that out in the UNESCO report that I shared, the source. We don't know the R square. We don't know if there's a strong correlation coefficient, okay? So whether this trend holds for average students, we do not know. So this chart only shows the correlation at the country level, not causation, or not at the individual level. Some very common misconceptions that I observe people jump very often is that girls perform worse because they lack confidence. It is very tempting because we see that self-efficacy is on the x-axis and the trend line slopes upward. But this is wrong because, first of all, self-efficacy is measured, but it's not manipulated. In other words, self-efficacy was not part of the intervention that they make, right? If it was manipulated, I know manipulation is a very strong word, but in research science, it is used to say that if we change the level, then we would see a causal relationship. But in this case, we're just measuring it. We're not manipulating. In other words, we're not varying the levels of self-efficacy. And cultural norms may affect reporting of confidence. Right? Another misconception is that boosting girls' confidence will close the achievement gap. It is also tempting, because it is an intervention friendly narrative, right? It is, though, unsupported because the chart doesn't test interventions. Confidence may be a symptom, right? But it's not a cause. It looks like a symptom, right? But it is not the cause. At least from this chart, we don't have that information. And then the key insight from this chart that we can conclude is that this shows an association, and the policy conclusions require causal evidence. This is just a correlation. This suggests a trend, but it doesn't give us the causality. Another misconception is that this explains gender gaps everywhere, all the countries. First of all, it is wrong because only top performing students are appearing in this chart, right, in this data. And averages hide within country variation. That's also very important. We need to differentiate. This is a cross-national pattern. It's not a global rule, okay? It's very important to understand that is not at the individual level. We collapse details into the context, and each dot is a country. Individual students are not plotted. Therefore, we can't say this is an individual level evidence. Okay, so if you want to read this chart critically, first of all, first identify the unit. These are the countries, not the people. Okay, the people are not the unit here. The unit of this analysis are the countries. And then look at the relationship. So you see the correlation, again, not causation. And then you check the spread, right? So there's a large scatter, potentially from weak to moderate relationship. Of course, we don't know the R square, the correlation coefficient significance. And then notice what is missing, what is absent. So we don't know the uncertainty bands, we don't know the confidence intervals, we don't know the effect size, we don't know what information are controlled for. Okay, so a line summarizes this trend, but it's still the variability, the uncertainty is still there. Some important questions to ask if you want to apply critical thinking to this chart when you're reading this chart. First of all, you can ask, how is self-efficacy measured? Or do boys and girls interpret the confidence questions similarly? Do they ever check if those groups interpret the questions similarly? Maybe it's just an interpretation issue, right? What about the causality? Could achievement influence confidence instead? Maybe it's the other way around. Just because there's a correlation, it doesn't mean that there's just one-sided. Maybe the other way around. Maybe those who are achieving more, they show more confidence, right? What about the third variable or fourth variable that might affect both, right? Maybe there's another variable, I don't know, maybe like the family structure, or the location of like the country, right? Or the social media exposure. Some other variables that affect maybe both, right? How about the scope? So does this apply to non-top performing students? We don't know. We can't overclaim that. We can't say all students actually are going to observe this kind of trend. We can't say that. This is for 15-year-olds and top performing students. And would this look at different at different ages? Maybe younger ages would be different. Maybe older students are going to be different. And what claim is supported and what claim would go beyond the data? These are important meta questions. What would we need to change in the data to make the causal claim? Because we know that this is not a causal claim, right? So what we can say again, this chart shows the positive association between gender differences in self-efficacy and science achievement across countries among top performing students, 15-year-olds. However, because the data are cross-sectional, aggregated, meaning like collapsed into one, right, averaged, at the country level, this chart doesn't establish a causal relationship or explain the mechanisms behind this association. It's not an individual relationship. That is data literacy. That is visual literacy.